There are these things called direction angles when we talk about vectors. And direction angles are always between 0 degrees and 360 degrees. We most commonly use degrees, not radians. Not radian measure, but we use degrees. And therefore, the direction angle, when you find it, is going to be greater than 0 degrees or equal to. It can be between 0 degrees and 360 degrees inclusive. So let's look at some of what I'm talking about. What I'm talking about, when you talk about vectors, you have your coordinate grid that you're going to be working with. So if I give you a vector, and maybe the vector is 0, 4. This is the component of the vector because on the x-axis, the horizontal movement, the 0, there is no horizontal movement, and of course that's x, and it's horizontal. Y is your vertical movement. And I just wrote movement instead of vertical. So we're looking at horizontal and vertical movement. And if this is the vector, then we can simply look at it and know that because the direction angle is the measure of the angle from the x-axis counterclockwise to that point, then we know that that angle, the direction angle of that vector is 90 degrees. Okay, it's kind of like the whole principal and principal thing. Like we have our principals, but we have a principal in the school. This is vertical, and hopefully it's spelled right now. Horizontal. All right, let's go with green for another particular vector. If we have a vector that is drawn here in green, its component form is, we've got a lot of horizontal movement here. So 1, 2, 3, 4, 5, 6, 7, 8. Our horizontal movement is a -8. Our vertical movement, there is none. So if we see a component form of a vector in this way with 0 in the y, then we would be measuring from the x-axis over, and the direction angle of that vector is 180 degrees. Doesn't seem too complicated or anything yet. Another vector that we could have would be this one in red. And of course it would be vertical, and then, it'd be in sync with the y-axis. But this vector movement, we've got 0 horizontal movement and 1, 2, 3, 4, 5. So -5 vertical movement. And the measure of that direction angle is 270. Because we measure it from here. Now we should be very familiar with these measurements. The 0 or 360. These are in degrees. The 90 degree, the 180 degree, and the 270 degree. Because those are going to be very helpful to us. Those measurements are going to be very helpful to us when we look at finding the direction angle of something that ends up in one of those quadrants, but not directly on the x or y axis. And finally, if we had a vector here, we're going to pretend that it stopped right on the 2, 4, 6, 8, 10, 11, and that's 11, 0, then its directional angle could be either 0 degrees or 360 degrees. But 0 degrees is what we would normally go with. Okay, let's look at some examples, and we'll come back to that. Let's find the direction angle of V equals 10, 0. So you don't want to have to draw a coordinate plane every time, so you kind of have to have one on the little dry erase board in your mind and think about where 10, 0 would be. And if this was just an example of the coordinate grid, then 10, 0 would be somewhere over here. And so we know that that would be 0 degrees. You can go with me on this. The direction angle of T is 0, 2. 90. That would be a 90 degree, because we would start at the origin and go up. And this is what we would measure from. The angle vector, or the direction angle of 0, -8 will be 270. And the direction angle of T equals -9J. Well, you have to remember what the component form, there are two component forms. This is telling you that the point is 0, -9, the terminal point of that, because it's not, it doesn't have any horizontal movement. Recall that the one of the component forms that you could have for a vector is that the vector would be equal to something I, that's not that kind of I, because that looks like an imaginary I, but something I plus something J. I being the coefficient of I would be the horizontal movement, or the X value, and the coefficient of B would be your vertical distance, your vertical direction, and it would include the plus or minus there. So with 0, -9, then we also have another 270 degree angle. Now, if we're talking about what would we expect to see if we had a directional angle of 180 degrees, there would be something particular about that vector. The x-coordinate would always be negative. It'd be negative some number, and the y value would be 0, because it wouldn't have any vertical movement. So those are the things to kind of remember for those four basic direction angles. But then we get to angles or vectors that do not have their x or y coordinate being 0. And this is what we will do for those. When x does not equal 0, the measure of the direction angle is equal to the arctangent of b over a. Now that's assuming that we have a either a component vector like -7, -4, or it could be written as -7i minus 4j, either one of those. So the reason that happens is because of the relationship, that trigonometric relationship, the ratio. The tangent of that angle would be equal to the sine of that angle over the cosine of that angle. We go back to unit circles. Sine of the angle is the y value, or b in this case, and then the cosine would be x. So if you have something like this, you're just going to kind of use your calculator and do the arctan, which in your calculator is tan to the -1 of b over a. And so here we would have -4 over -7. Now, when we do that, let's pause here and actually do that with our calculator. So on this one, of course, we're going to go from the very beginning. If we're measuring in degrees, we need to make sure that our mode is in degree mode. And then we have the tangent, the arctangent of -4 over -7. And that's taking the y value first, or the coefficient of j, over the x value. And of course, you can eliminate the negatives, because negative divided by negative would be positive and all that. You can do all that. It really doesn't matter, although this will matter in what we give our answer. When we press enter here, we get 29.74. But I know that when I look at this point, that it's not going to be 29.7 if I were rounding to the 10th, because -7, -4 is somewhere in the third quadrant. So it can't be 20 some odd degrees, because -7, -4 would be here. And so if that's our vector, I'm not a good editor, so if you want a really clean, pretty video, you might want to go find somebody else. Because this is when we're in class and people make mistakes. So 2, 4, 6, 7, -4. I'm still thinking I'm making mistakes. So we're over here in the third quadrant. So we wouldn't expect our direction angle to be, let's bring back up, yeah. All right. Let's go away from that because that always takes too much time. And let's look at this. And I'm going to make mistakes. I don't know why, but I am. So let's bring the calculator back up. And we know what we needed to do, which was to find the arctan of y over x. And we get this 29.74. But when we think about the point, -7, -4, then we know that it's in the third quadrant. So we know that the measure of that angle has to be between 180 and 270. So you think, well, what should I do with this 29.74 to make sure that that direction angle is in the third quadrant? Let's add 180 to it. If that's what you're thinking, you're exactly right, and you would add 180. Now, sometimes, depending on where that direction or where that vector, what quadrant it is in, you're either going to be adding 180 or maybe adding 360. So that's basically what you're going to be doing. If you end up with a negative value for the arctangent, then you're going to probably, depending on where it is, you're going to be adding 360. So let's pause here while we do the 3 on the right-hand side of this screen. Wow. So you can check your work here. This is using our technology, using the calculator to find the arctan, and then using what we know about the quadrant that particular vector is in to determine whether we should add 360 in the first two, because we know that they're in the fourth quadrant, or on the third one, -4, 7, that vector is going to be in the second quadrant, which means that x has to, it'll always be in the second quadrant when x is negative and y is positive. So when you see a vector, a direction, or you're finding a direction angle on something with a negative x and a positive y, you're going to be adding 180 to what you get for the arctan of that vector. And that's all I have to say about finding the direction angle of a vector.